please hit subscribe.
Let us now show how to arrive at the limit of this expression. That is the limit of n, or rather the nth root of n as n approaches infinity. This is a common limit and most people know this by heart, and we will show how to prove that that is in fact the limit. So let us first realize that if you have the expression nth root of n, it will always be a positive number, because if n is a positive number, whatever value that is, if you get the nth root of that, it can never be negative. And so we say that this expression is always greater than or equal to 0. And if we for a second suppose that that value is r, suppose that is r, we notice that r to the n equals n. And if n is greater than 1, if n is, okay, let's start with n equals 1, then r to the n equals 1. But if n is less than 1, then r to the n is less than 1. And if n is greater than 1, then r to the n is greater than 1. And clearly we know that n is always greater than 1, right? Because we have n as a number in the set of natural numbers. And so it's greater than 1. And we are also letting n approach infinity. So that's why we think that n is greater than 1. And so we have the intuition that r to the n is greater than 1. And because of this, we can also say that r must be greater than 1. That's because exponentiating by n is a function that always increases. So it's an increasing function, and therefore if you have r greater than 1, then r to the n is greater than 1. And so we now have a clue that r is greater than 1, and that means that r, which is equal to the nth root of n, is greater than 1. If that is the case, then we can express r, or the nth root of n, as 1 plus some positive number, epsilon. So epsilon is a positive number. Now, this is a good form, because if we raise both sides to n, we get 1 plus epsilon raised to the n. And if we apply the binomial theorem, we get the following. Now, we will state our guess. Our guess is that the nth root of n, as n approaches infinity, the limit is 1. And so we want this epsilon to go to 0. And so, because that is our guess, we will find an expression that is less than n. And we will see why that is the case. So what I will do is I'm just going to choose just one term of this expansion. And the term I'm going to choose is e epsilon squared n times n minus 1 all over 2 factorial. And the reason we chose this is because now, if I just write this again here, now I can cancel the n's from both sides. So what I get is 1 is greater than e squared n minus 1 all over 2 factorial. And then, if we rearrange that a bit, we get 2 over n minus 1 is greater than e or epsilon squared. And so, we also know that epsilon is a positive number. So we can do this. And now if you take the limit of the terms as n approaches infinity, I wrote 0, but that should be infinity there. We probably actually had to get the square root first so that we can do this. And now, because we know the limits on the left and on the right, so this limit just goes to 0. And this limit just goes to 0. Therefore, the limit as n approaches infinity of epsilon is equal to 0. And what that means for us is that the nth root of n as n approaches infinity is equal to the limit as n approaches infinity of 1 plus epsilon. And because we already know this limit here, we'll have 1 plus 0 equals 1. And therefore, the limit that we're looking for is in fact 1.
Please hit subscribe.